Hello, algebra students. We're already on 11:8, nearing the end of chapter 11, and then we only have 12, and we're done. It's crazy. So we're going to talk about multiplying and dividing radical expressions, and that is, of course, the square root. I would encourage you to, right off the bat here, take super clear notes, because I'm going to ask you to do something at the end of the video. Okay, so I'm telling you ahead of time. All right. So we're going to go ahead and multiply. Now remember, if you have two radicals like this and you are multiplying, and we are multiplying because there's nothing in between here, so that means it is a multiplication problem, you actually can multiply what's inside of them. 8 times 6 is 48. Now, it also says write each product in simplest form. So we always have to look at that answer and say, oh, can we break it down? Okay. Is there two numbers, and we talked about this before. Remember, 1 squared is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Here's the short list, because that's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc. So we're trying to think is, does this divide by any of these? And the answer is yes, it divides by 16, 3 times. So I can rewrite this as the square root of 16 and the square root of 3. Now we wouldn't be able to get here from here. I mean, you can, but it's a little bit longer. So it's kind of weird, I know, because you multiply only to break it apart again. But the reason is square root of 16 is 4, and the square root sign is all gone. And square root of 3 doesn't reduce, so there's your answer. Okay, another type of problem you might see is when you see this little square up here. So remember, that square gets applied to everything in here. Okay, so this is really the same as if you had 2 squared times square root of 5 squared. Okay, that little 2 goes to each of them. So now 2 squared is 4. And do you guys remember that the square root and the square undo each other? They cancel each other out. It's like plus and minus, or multiply and divide, square root and square. So those cancel each other out, and you're left with the number on the inside. So our number for that is 20. All right, the next one, it says multiply again. There's nothing between it, so we know it's multiply. And I'm going to multiply the numbers first. 3 times 12 is 36. Y times y is y squared. And then since these are multiplied, again, this is very tricky because if this was a minus, we couldn't do this. But because it's a multiplication, you can view those each separately. I can break that down again. And do you see what happens? Yeah, square root of 36 is 6. And again, they undo each other, square root and square. So what are we left with? Just the y. All right, you taking good notes? All right, now notice what comes up in these is our addition and subtraction. So it's a little bit trickier, but it's kind of like when we used to have variables on the inside. You have to multiply anything on the outside of the parenthesis by however many terms are in the inside. So how many terms are there? 1, 2. So I'm going to do 2 multiplications. Square root of 3 times 7. You always want to put the 7 out front, otherwise it's going to look like 37 under the square root, and only the 3 is under the square root. Minus, and then we're going to multiply these. And remember, when you multiply 2 square roots, you multiply what's on the inside. And I get 24. Now when I look at this, and we again have to have everything in simplest form, as we said up here. So when I look at this, square root of 3 can't break down anymore, but square root of 24 might be able to. Can you think of one of those numbers up here? And it's going to be on the lower end because it's a small number that 24 will divide by? That's right, the 4. So this can be broken down into square root of 4 times the square root of 6. Okay. Now this in the front isn't changing, so I'm just going to rewrite it and put my minus so I don't forget about it. But rewrite it again. Square root of 4 is a 2. Square root of 6. Now, if these were both square root of 3, 3. I could put them together, but I can't because we're subtracting, and it's kind of like the x's. Remember, you can only put x's together. You can't put an x and a y together. Same thing when you're subtracting with square roots. So this is as far as we can go with that one. So if you want to pause and try the next one, go ahead. Otherwise, you can just follow me through here. So when I multiply those two, I get the square root of 2 times 8, which is 16, plus square root of 2 times 18, which is 36. Ooh, this is going to turn out slick, isn't it, class? Because the square root of 16 is 4. And the square root of 36 is 6. And I had an addition sign between them. Ding dong. There's our answer. All right, now another slightly different one is this had one value out front and you multiplied it by the 2. Here we've got 2 terms in here and we've got 2 terms in here and we're multiplying them. So it was like those long, some of you use the term FOIL, but it's also just remembering that we're multiplying the 3 by both of them and we're multiplying the square root of 8 by both of them and making sure to keep the sign because I see that we got a negative here before the square root of 8. Okay, so let's give it a shot. So 3 times the 2 is 6. Well, that's nice. We started off nice and easy. And then 3 times the square root of 8 is, and it's a plus, 3 square root 8. Then I go to the next term. I have a negative square root of 8 times 2. So it's a minus 2 square root of 8. So the negative and minus kind of are interchangeable there. Well, not kind of, they are. All right, and then the next one is negative square root of 8 times positive square root of 8. So I'm going to have a negative. And remember, when you have 2 square roots, you multiply what's on the inside. So 8 times 8 is 64. All right, let's see where we can go with this. I'm seeing one thing kind of cool. Does anybody see it? And some of you might see square root of 64. Did you see that? Put the minus. Don't lose your minus. That's right. Anybody else see this part? They both have the same square root of 8. So that means we can put those together. So when we do that, we take 3 minus 2, which is just a 1 square root of 8. And of course, we have the 6 out front. We don't usually put the 1. I just put it there for you to see that. And we have any other like terms we can put together? Yes, we do. We got a 6 and a negative 8. Those are both just integers. So I have a negative 2 when I add those, plus square root of 8. They're getting there, but we always got to double check. Does the square root of 8 break down? It does. So we have one more step. Square root of 4 times square root of 2. I'm going to have to go over here. Got the negative 2 out front. And then the square root of 4. It's a plus, so I put a plus. 2 root 2. Woofda. We're there. So you can see why the work is really important. So you don't get lost, you don't miss a sign, etc. When you look at this one, remember this squared. It means this whole thing times this whole thing. Okay, so I'm going to have to rewrite this. All right, now let's multiply like we did over on this side. We'll do the 4 times the 4, which is 16, plus the 4 times the square root of 3, plus the 4 times square root of 3, number first, plus square root of 3 times square root of 3 is square root of 9. Now we look for like terms. Nice. We got 2 square root of 3, so I can add these numbers in the front. So I have plus 8 square root of 3. And nice, square root of 9 is 3. So that reduces. Again, we've got these. 16 plus 3 is 19. I cannot add these two. This 8 goes with the square root of 3. I cannot add the 19 and the 8. Nor could I add the negative 2 and the 2. Okay, this is glued together. Can't just pull part of it out. All right, the last thing we need to do today, then we'll be all done, is simplifying a quotient. So we did a lot up here with all different kinds of multiplication. But, excuse me, this is called rationalizing the denominator, which you will hear that term. And what that means is it is not considered proper form to have a square root in the denominator. Okay, you can have it in the top, but your final answer should never have a square root in the bottom. So we do what's called rationalizing the denominator. And I'm actually going to write this here because you'll see that on tests too when you do standardized tests. Rationalizing the denominator. So I want you to be familiar with those words as well. But in order to get rid of the square root of 3 on the bottom, all you do is multiply by the exact same thing that's in the bottom. Okay? Because class, what's square root of 3 over square root of 3? 1. So I'm not changing this. I'm just changing the way it looks. Okay? So let's take a look at what we get then. We get the square root of 11 times 3 is 33. But watch what happens here. Square root of 3 times square root of 3 is square root of 9, which is what? 3. And that will always happen. The square root of 2 billion, I'll just put 2,000, times the square root of 2,000 is, guess what? 2,000. Okay, because you're going to get the square root of 4 whatever. And then you're going to take the square root and get your 2,000 back. Okay? So there's your final answer. No square root in the bottom. And the square root of 33 does not reduce. So let's look over here. The top you can't do anything with. Square root of 13m is square root of 13m. But the square root of 20, before I just get too happy to go over and multiply by square root of 20 on top and bottom, I want to simplify this. Okay, I want to break this down because I can see that there is a number 4 that I can take out of there. So I'm going to break that down into square root of 4 times square root of 5. Square root of 4 is 2. So now I have this. So I don't need to multiply by square root of 20. What do I need to multiply the top and bottom by? Square root of 5. Very good. And the reason that's important is because you're keeping things smaller, and it's a lot easier to reduce when you have a smaller number than if you would have multiplied the 20 by the 13 and had this huge number on the top. Okay, so that's why we want to do this first. Now, let's multiply. So 5 times 13 is 65. So we have square root of 65m over, what's square root of 5 times square root of 5? What do we say here? Get the number right back, right? Because it's the square root of 25, which is 5. So I have 2, don't forget the 2, times 5. Answer. There you go. All right, class. So you should have really good notes. I asked you to take them. Go ahead and snap a picture and send it to me. Okay? All right. And I'm going to just throw an extra credit point onto your homework for today. So just snap it and email it right to me. Okay? Sounds good. I won't always do that, but occasionally I'll do it just to kind of see who's in the game here. It's good to see who's watching the videos and keep track and stuff. It's people don't get docked for not watching the videos, but it sure should help you guys. All right. Take care. God bless.